analyzers, let's talk about your Chapter 3 Quiz number 1 review, which is lessons 1 through 5. We've got equations and inequalities galore. Let's solve, right? Got lots of things going on. First and foremost, if you've got an inequality sign, you're going to have to graph the solution set on a provided number line. So you'll notice that just numbers 1 through 4, I know I've got an inequality sign on number 1, and I know I've got a number line on number 1. So just a real quick, all right, distribute. Bring down your negative 18, you're greater than or equal to, you got 6x minus 54. Okay, now let's move the 54 away. So plus 54 on both sides. You guys are knowing the difference between your your negative and your minus sign, right? So negative 18 plus 54. So you know the difference, right? So you get 36 is greater than or equal to 6x. Now to get x all by itself, you divide both sides by 6, nice and quick. You get 6 is greater than or equal to x. I don't keep it that order. I always put my variable on the left. So I'm going to just flip everything around. And because saying it this way makes more sense to me to put my answer on the number line, which is x is less than or equal to 6. So 6 is my number in question. I'm going to put a couple on each side. And because my hash marks are so small, I'm kind of skipping. But 6 is my number in question. It gets a closed dot. And x has to be less than or equal to 6. So less than left. There you go. So not only do you need the answer, you also need, for an inequality, to have the solution set on a number line. All right. Let's do number 2, LCD. I've got lots of denominators. My thing I like to do with this is I like to factor my denominator, my bigger denominators. I'll note that these two are the same. So if I just factor it once, that should be plenty, right? All right, so let's see. They both got an x squared as their minimum. Yikes. And then my leftover is x minus 2. Okay, so that's there. You can pull that out of both of them. So if I think, okay, x squared is x times x. So really, if I put it this way, and so I've made that x squared into x times x, I can very easily multiply to get this as one of the denominators if this is my LCD. So my LCD is going to be this whole thing, x times x minus 2. And I'm going to keep it out factored that way so that it'll be easy to cancel. Okay, and I know I've done a lot of writing right there, so I'm going to just make myself a little space here for this particular question, because I'm going to have to write all out multiplied by the LCD right after I say what x isn't allowed to be. X is not allowed to be 0, because we got an x right here, and if it were 0, that'd be bad. World would implode. World's bad enough as it is. Please don't put 0 in a denominator. 2 minus 2 is 0, so x can't be 2 either. We better watch it. None of those answers for x. Now take your LCD and multiply it by every single piece, okay? So your LCD is these pieces all multiplied together, okay? Now multiply it by 5 over x. Okay, minus. Your LCD is all of these pieces. Hopefully I can cancel some of these pieces out. I think I'll get lucky. Cancel some of them out. Looking good, because that's 2 denominators, right? Right. Okay, and then on the other side, yikes. Ugh. Gotta multiply it all by the LCD. X minus 2. Oh, accidentally wrote on my tie-dye sheet here. Okay, let's cancel. Let's do some canceling. There we go. All right, x can cancel. but all this is left. So you know what I'm going to do to keep my life a little bit easier? I am just going to bring it all down to the next line, and then I will distribute it all on the next round. Okay, but that's all that's left, all being multiplied together. Now on this one, this is kind of nice because this whole thing, remember, factored to become this, what is my LCD, right? So this whole thing cancels out. And really, since I got this minus out here, I'm just left with -6. So that's nice. Over on the other side, same thing happened. The whole LCD is gone and just my numerator remains. So, okay, that looked like it was going to be absolutely awful. Now it's just, not great. Well, let's distribute over here. X times x is x squared, and x times -2 is -2x. And then that still has to be multiplied by a 5. So notice I'm just kind of taking it one step at a time. I'm not trying to get ahead of myself here. Now let's distribute the 5. So you get 5x squared minus 10x minus 6 equals this x squared plus 5x minus 6. So now the one side that has more x squareds is the side you want. So let's get everything over there by moving them oppositely. Okay, let's see. 5x squareds minus 1x squared is 4x squareds. Good. Oh, did I add those already in my head? That's supposed to be a minus 5x squared, right? Or excuse me, minus 5x. Negative 10x minus 5x. That's a negative 15x. So I must have just like added those in my head as I was moving them over. That sounds like me. -6 plus 6, that cancels to 0. So I don't have a number here anymore, which is good because this is factorable. This has a GCF of x, and its leftover is 4x minus 15. It's not pretty, but it's factorable. And when I factor it, I set each side of my t-chart equal to 0, right? So one answer is already done for me, x equals 0, which we'll talk about in a second. Over here, I now have to just add 15 to both sides. And now I divide both sides by 4, and I get x equals 15 fourths. Or you may say x equals 3.75, which you're allowed to do it that way too. Either of these. I'm going to box this one in because when I look back up, x was not allowed to be 0 or 2. And what did I get over here? X equals 0. I've got to reject it. Done. We get to keep the fraction, not the 0. Bummer. But we can't have 0 in a denominator. We've already got a global pandemic. Don't explode the world too. Okay. Hey, number 3, still fraction, but a little easier. You guys okay? I know. Still fraction, but easier because this is a proportion. Only one fraction set equal to one more fraction. So you can just cross multiply your little heart out. So this is really 8 times 11x minus 2. Okay, and over here, this is really 2 times 14. All right, that's what's really going on here. So let's see, we get 88x minus 16 equals, what's that, 28? And now let's add that 16 over. And you get 88x equals 44. Divide both sides by 88. And I get x equals, both divisible by 44, 1/2. Not bad. Fractions and decimals are very common as answers, and they're okay. Go ahead and get those. That's just fine. Another LCD question. This time, quite easier denominators, right? I'll just do it right here that your LCD is your x squared, and x cannot be equal to 0. And now take x squared, being your biggest denominator, and multiply it by every piece of your equation. Now, when there's denominators, they'll cancel with your LCD. So, like here, that's just completely gone. They're exactly the same number, and any number divided by itself is 1. So, 1 times 14 gives me 14, which comes down to the next line. Next, here, watch the minus in front of this, but x squared divided by x, well, the squared part is gone. Now the x is gone here, and you're really left with negative x times 5, or minus 5x. On the other side of the equal sign, there is no denominator for my LCD to cancel with. So 1 times anything is itself. There's where my x squared stays. Now that I see the x squared on the other side, better move these two over because this is a quadratic. 0 equals x squared plus 5x minus 14. What are the factors of 14 that subtract to give me a positive 5? That would be a positive 7 and a negative 2. What was x not allowed to be again? 0. Got it. Okay. So it looks like here, just double checking because I'm setting each equal to 0 and I'm getting x equals negative 7 and x equals positive 2. Those are okay. Those are okay because x wasn't allowed to be 0. So I'll keep those guys. Alrighty. Continuing. Oh, joy. Some absolute value. Love some absolute value. Got to get absolute value alone. Now, I do notice that I've got an inequality sign here, so I'll have to watch for flippage. Okay, watch for inequality sign flippage, so be careful. First things first, there's a lot around my absolute value bars, so I have to start by, let's add that 10 to both sides to start, get rid of it. You get 5 times the absolute value of n minus 2 is greater than 60. Now divide both sides by 5. You're dividing by a positive number, so there won't be any inequality sign flippage. Okay, we're good here. So let's do our two scenarios. Scenario number 1 is n minus 2 is greater than 12. And scenario number 2 is n minus 2 is less than negative 12. Because remember, you're negating the other side. And if you're multiplying the other side by negative, then your inequality needs to flip over. So now solve each side for n. You get n is greater than 14 over here. N is less than negative 10. So you have kind of a range you need to fit on your number line. You just, go by twos, whatever. So like negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12, 14 right there. There you go. So I went by twos when I was scaling. Open circle over negative 10, open circle over 14, and n has to be greater than 14, so off this direction. N has to be less than negative 10, so off this direction, and that means I need to write an or in between. Just like that. Have to write that or in between for my final answer. Pause if you need to. Ask me questions if you need to. Number 6, another absolute value. Looks like we got a few absolute values here. Let me move this cursor. It's driving me nuts. Oh, got to get absolute value bars alone first. So I need to start by multiplying both sides by negative 10. All right, so that cancels here. Leaves me with my absolute value bars alone. Fingers crossed. Is there a negative on the other side? Negative times negative. Negative times negative is a positive. Still got to keep going. Not a no solution. It's an equal sign, though. Two scenarios. X plus 4 equals 10, the regular. Now, the other scenario is x plus 4 equals negative 10, the negated side. All right. Get that x alone. Cool. Get that x alone. Cool. There's 2 answers. That's it. That's not an or. I don't know why I did that. That's either. That's and or. I don't need an or. It's not a number line. Sorry about that. Two answers. Two answers. Both of them. Oh, here's hoping we get a negative on one side of one of these absolute values, huh? All right, this one's tricky. Move this 10 first. Do not subtract these to start. Move this 10 first because this is attached here by multiplication. So you've got to leave this negative 10 here for the time being. So let's start by subtracting that 10 from both sides. So you get negative 10 times all this absolute value junk equals 10. Now divide both sides by negative 10 to get your absolute value bars alone. So now my absolute value bars are alone, and oh yeah, there's a negative on the other side of absolute value bars. That's a no solution. Absolute value bars are not going to produce a negative number. So if you see that once your absolute value bars are alone, you can stop and say no solution. But you've got to show the work to get them alone first. Be careful of this. This negative 10 is attached here by multiplication. These do not subtract first. So be very careful of that. Get that absolute value bars alone first by starting by subtracting that 10 over. Same here, right? This is actually kind of the same scenario, except that the 17 isn't in front of the negative 9. That's what the trick is on number 7. Okay, but do start by subtracting that 17 over. You get negative 9 in front of the absolute value bars, blah, blah, blah. We don't care about those yet. Equals 8 minus 17 is negative 9, right? That feels too convenient. Oh, okay. All right. It just felt too convenient in my head. Because now I'm going to multiply both sides, or I'm going to divide both sides by 9. Jeez, negative 9. So that gives me my absolute value bars alone. And negative divided by negative, it's a positive 1. Okay. It's still two scenarios. So my first scenario is drop the absolute value bars, set equal to 1. My second scenario, drop the absolute value bars, set equal to negative 1. That's you negating the other side. This is easy from here just because the opposite of dividing by 3 is multiplying by 3. So hope you didn't panic seeing a fraction. It's just the opposite, right? 1 times 3 is 3. There's one answer. Over here, multiply both sides by 3. And negative 1 times 3 is negative 3. There are your two answers. Okay? So far, so good? How are we doing, guys? All right. And a couple more. Here we go. Okay. Oh, got another good LCD here. We've done an LCD very similar there. Multiply both sides here. Oh, 12 is easy. Start with 12. Multiply both sides by negative 8. And you get x plus 15 equals 16. Oh my gosh. Subtract 15. Don't let a fraction panic you. That was so quick and easy. Don't let a fraction panic you. The opposite of dividing by this denominator is multiplying by the denominator. Okay, don't let that panic you. Distribute up here. Let's do the easy ones. Distribute up here. 2x minus 6, right, is, well, negative 28 is less than or equal to 2x minus 6. Let's say it correctly. Add 6, add 6. Cool. I get negative 22 is less than or equal to 2x. So let's divide both sides by 2. And I get x. And my negative 11, but I don't like saying it that direction. I really don't. Negative 11 is less than or equal to x. It just doesn't equate well for me putting it on the number line. So I flip it around. X is greater than or equal to negative 11. Now see, to me, mentally, that makes more sense putting my solution set on my number line. So negative 11 is my number in question, and I'm just going to put a couple of numbers on each side. That was there, so that's there. Sorry, I started writing it in a weird place. Okay, now negative 11 gets a closed dot, and x is greater than or equal to negative 11. Cover all the things bigger than negative 11. So that's how I write my answers. I always write my variable on the left. 2 more LCDs, then we're done. So number 10, okay, I'm going to factor this big denominator here. There's a GCF. All right. And if I look, these can easily become this by multiplication if I just took the binomial and multiplied in each spot, right? So that's going to make that my LCD. The whole thing, that big denominator, is my LCD. And I'm going to leave it as the factored pieces because it makes it easier for me to figure out what x cannot be equal to. And it makes it easier when I'm going to multiply it by all the pieces of my equation and canceling things out. So I leave it as the two pieces. What can't x be? Oh, x can't be 0 for sure, because you can't put a 0 here. And then if we think about this, if you put 3 here, right, what's 3 minus 3? It's 0. So you can't have 3 as an answer for x either. So we're going to have to watch out for those as we go. Now take this entire LCD and multiply it by every piece. I'm going to do it this way, of my equation. So rewrite this, x plus 2 over x. Okay, now let's do it again. Equal sign, x, x minus 3, x minus 1 over x, just like that. X, x minus 3, 4x plus 2 over x squared minus 3x, just like that. Oof, almost got too big for a second there. This one's kind of easy because the x's cancel, but now you've got two binomials that are going to have to multiply together. So let's rewrite them down here so that we remember to FOIL them. Also kind of easy, crap, we got two binomials that are going to multiply together. So let's write them down here so we remember to FOIL. Oh, okay. This is nice because remember, this is the denominator we factored into this, which became our LCD. So this entire LCD is exactly the same as this denominator. So they completely cancel. What you need to be careful of is this negative needs to be distributed to both of these. This is like you left a -1 in the front. So now you get negative 4x minus 2. So now we're going to FOIL on each side. X squared plus 2x minus 3x minus 6 equals, let's FOIL again, x squared minus x minus 3x. Here, I'll put a 1 in front of that since that makes most of you feel better. Plus 3 minus 4x minus 2. Just brought those guys down. We'll combine like terms on the same side. X squared minus 1x minus 6. And, oh boy, oh boy, oh boy. Minus 8. And numbers. Oh, forgot my x squared. Sorry. There was nothing else like it, so I couldn't combine it with anything. Bring it down. Plus 1. Hey, actually, what happens to my x squareds? They cancel out, because if I go to try to move them to be together, right? 0, 0. Done. So let's actually just add 8x here. And I get 7x. And let's add 6 here. And I get 7. Oh, nice and easy. What wasn't x allowed to be again? 0 or 1, or excuse me, 0 or 3? Good. We're good. Passes. Nice and easy. Whew, looked so complicated. Ended up having some canceling, so we're okay. Right? That's why you got to try them, because they look like they're going to be really difficult. And we get enough cancellations occurring that they end up not being that difficult. All right, last one. We've seen LCDs like this before, but let me just remind you. So separate binomial LCDs, right? If you were to take and multiply these two separate binomials together, that would give you a usable LCD, right? So my LCD is going to be x plus 3 times x minus 2. And what that means that x cannot be equal to is -3 and +2. Do you see how it's opposite of what the signs are inside the binomials? That's what would make it 0. Alrighty, let's take that LCD and multiply it by every piece. This is the part that takes time and space, but is really important for getting it right. Really taking my time here. X plus 3, x minus 2, and 6 2. Got it. You know, if I'm ever going too fast, pause it too. Make sure that you're staying with me, right? That's something that you don't get to do in class with notes. You don't get to pause me while I'm talking during class. Must be nice. Wish I had a pause button for some of you guys. Anyway, I'm sure I got some of you riled up. Here we go. Look at this. This entire thing. X plus 3. X plus 3. Gone. All you're left with is x minus 2. Bring it down to the next line. The entire x minus 2. Gone. Now, yeah, okay, you've got two binomials here. Bring them down. We'll FOIL them down here. Just rewrite them down here. No pre-foiling, okay? Don't pre-foil. Over here, we've got x minus 2, x minus 2. So those cancel out. Distribute that 6. So 6x plus 18. There you go. Okay, so here you want to FOIL. Okay, you got x minus 2 plus x squared plus 4x plus 3x plus 12. Oh, now we'll combine like terms on that side. So let's see, nothing else like the x squared, bring it down. Then you got x plus 4x plus 3x. So that would be an 8x. Then you got negative 2 plus 12, that's going to be a plus 10 equals 6x plus 18. All right, now you got an x squared, so move these guys over by opposites. Get all the stuff on the same side as the positive x squared. Always leave that x squared positive. And you get a positive 2x and a negative 8. And what are the factors of 8 that will subtract to give me 2? That would be 4 and 2. Positive 4, negative 2. Oh, man. What was an x allowed to be? We're going to have a reject here, guys. Not this one, but this one. Right? Because x was not allowed to be negative 3 or positive 2. So you don't get to keep that. Bummer. All right. Well, hey, go back and look at any of these. You need to. Ask me questions about any of these if you need to. But this is what's getting you ready. Okay, getting you ready for your test. Right? Oh, excuse me, quiz. Your first chapter 3 quiz. There's 2 chapter 3 quizzes and a test. Right? So this first one is all about the first 5 lessons. So solving linear equations, solving linear inequalities, solving absolute value equations, solving absolute value inequalities, and LCD equations. That's what we're looking at here. All right, my fine friends, I shall be seeing you. Let me know if you need anything before that quiz in Delta Math. And yeah, I'll see some of you in class and others continuously this way. Bye, guys.